So in this video I continue with looking at the derivmkts package which is available in the rstudio suite, and I ran an estimation here for Cox Ross and Rubinstein tree. It produced an output that we verified for 997 for a call option with these parameter values, so S100K 100 R equal to 5%, T equal to 1 year, R no dividend, so dividend 0, and for 4 steps. Okay, now one of the nice features about this model is this package, the derivmkts package, is that it also allows you to plot out the results. So I've went through again. This is what's in our script. We set out our parameter values. We ran this snippet of code here. We then produced the entire output for the tree, for the option price tree, the parameter values for P, U, and D, which I found consistent with manual estimations that I've done. And then if I take the same results again, for the Cox Ross Rubinstein tree, again, we can put in for a 4-step tree, so it shouldn't be so specific. So 4-step tree, not American, we can say false, so not American, so false, F-A-L-S-E. Cox Ross Rubinstein true, return, again, that should be for plots actually I'm looking for. So for binom plots, put option false, so it's a call, American false. Okay, so that means then it's European. This option won't exercise anyway if the dividend is 0 and R is positive. Plot values true, plot arrows, draw, strike, okay, true. Okay, so let's just run that and see what we get out. And we get a very nice graph, right? So one of the nice features here in terms of the pricing the option is we get a nice graph for the tree, so that's the stock price tree, and again we can compare that either here with the stock price. Okay, 100, the stock goes up to 110.5 or 90.5, 122, 122, and so on up to 149. Again, that's useful in that we're able to corroborate the results that we obtain, and we can redimension that to suit whatever purpose is necessary. Also, when we examine the tree here, you might note that the green nodes here denote early exercise, and so early exercise is captured here in the true, true, and true, right? Also, the size of the dots seems to be linked to the probability tree. So we've a node of 1, then 0.53, a bit smaller below, and so on. So there seems to be correlation here between the size of the options and the probability tree. So again, this is a powerful way of presenting some of the dynamic features in the tree. If we increase the step size, we go back in, increase the step size. Let's pause. Okay, if we increase the step size to 15 for a moment, 1.5, right, and then run that, so the values changes to 15, and then come down to our binom plot and run. Again, we get a much bigger, more complex tree. Again, we can go to zoom, and when we look at that, we have, again, we can see the dynamic behavior of the tree. Again, it's not straight lines, it's curved, and again, that's what you would expect when we increase by u each time, u squared. This is non-linear, and we would expect some curvature here. Also, we cannot have a negative value for the stock, so this is a log normal type distribution, and that's also characteristic here of the binomial shape. We also, if we go back to the binom up and then print out, we can also view the tree here as well. So let's take the stock price, if I can find a stock price tree for a moment. Okay, this is the stock price tree. So these values here, 216.97, 217, 195.68, 195.7, and so on. Okay, so if we widen this out, if I ran that, if I squeeze this and run that estimation again, just to give some space here to fully view the output, so binom up, okay, we get the full, we can see the tree here in full, which is convenient perhaps if we wanted to copy and paste into Excel to review the tree. Okay, a 15-step tree will have 16 rows and 16 columns, right? So that's also something worth noting. Okay, that's probably makes a little bit more sense when we can visualize, but it's a nice, efficient setup, and it provides obviously a relatively fast way to set out the option price tree, the stock price tree, and so on, and obtain the parameter values as well. And if we want to test in Excel our tree, whether it's a Cox Ross Rubinstein tree, Jarrah Rudd, and there is also another tree specification in what's available here. We could have a look maybe to verify that. If we go into the packages for a moment and look at the binom up, there is Jarrah Rudd, there's Cox Ross Rubinstein, and I think there's one other type of tree as well available here. So lots of flexibility. And overall, this is a very nice, efficient package. So it's deriv, markets, and for a range for binomial option pricing, for Asian option pricing, even bonds, and so on. There's a lot here, all for Greek estimation, implied volatility. Okay, so there's a lot here. Okay, and worth exploring.